hydrogen-powered trains work? While there is potential to power trains with hydrogen using converted combustion engine, current technology focuses on the use of hydrogen fuel cells, which generate electricity using a chemical reaction between two electrodes, a negative anode and a positive cathode. Hydrogen acts as the fuel in the cell with the addition of oxygen, generating electrical energy with water being the only byproduct. Hydrogen is the most abundant element in the universe and can be separated from seawater. The technique used to obtain the hydrogen has an impact on how environmentally friendly the hydrogen is. Steam reforming, for example, uses harmful fossil fuels, while electrolysis using renewable energy electricity or excess power from the grid creates no carbon emissions. Proposals for Hydrail include producing hydrogen fuel at individual maintenance depots, which can then be pumped into pressurized tanks on the vehicles. Fuel cell technology advancements have improved the viability of hydrogen-powered vehicles, with the weight of the fuel cells reducing and the efficiencies improving. Fuel cells convert chemical energy within hydrogen into electricity, also creating water and heat. This is the inverse of the electrolysis process that can be used to create hydrogen fuel, although there are energy losses involved in these processes, with reports saying the efficiency of converting electricity to hydrogen and back again being just below 30%, which is roughly equivalent to diesel engines but less than with electric traction using overhead wires. The electricity produced by the fuel cells is fed into a motor to power the train. Unlike natural gas or diesel fuel, hydrogen produced by electrolysis produces zero emissions, while hydrogen produced by steam methane reforming still produces emissions 45% lower than diesel trains. However, for the rail industry to move towards Hydrail solutions will require investment in the hydrogen production and distribution network. Why hydrogen? The use of hydrogen and, in particular, green hydrogen as a rail fuel offers a range of benefits, including supporting zero-carbon goals as a clean energy source and offering more powerful and efficient energy output than with fossil fuels. Unlock industry-leading expertise and solutions in materials joining and engineering technologies. Join for exclusive access to cutting-edge research, expert advice, and a global industry leaders. Empower your business with the tools and expertise to innovate and stay competitive. Start transforming your operations today. Hydrogen can be carried on board trains and used on lines that do not justify the cost of electrification due to the low frequency of services, such as for rural train services that currently rely on diesel. Battery power has also been explored by rail companies, but they are currently unable to store enough electricity to power a train and so are only really of use as a hybrid backup power supply for some applications. Hydrogen train examples. Alstom presented the Coradia Island trademark symbol for the first time at InnoTrans 2016 in Berlin. Emitting no carbon dioxide, it became the world's first hydrogen passenger train powered by hydrogen fuel cell technology, entering commercial service in Germany in 2018. The clean energy, zero-emission train releases only steam and condensed water as well as emitting low noise levels, using a combination of hydrogen fuel with battery energy storage. The UK's first hydrogen-powered train, the Hydrophiliax, was launched in 2019 and is based on a Class 319 train fitted with hydrogen fuel tanks, a fuel cell and a battery pack. This bi-mode electric hydrogen train converts hydrogen and oxygen to generate electricity and also has 2 packs of lithium-ion batteries for energy storage. Further developments are expected to improve the train's level of power and performance. How fast can a hydrogen train go? Hydrogen-powered trains can achieve speeds of up to 140 km/h and manage distances of up to 1,000 km without refueling, which is 10 times further than battery-powered electric trains. The refueling is also fast at less than 20 minutes. Can trains run on hydrogen? Hydrogen fuel cell trains can run on hydrogen with just water and heat being produced as a byproduct. These trains are a good alternative to diesel-powered locomotives where railway lines are not powered. Are hydrogen trains safe? Hydrogen trains are safe, as shown by investigations into the safety of hydrogen-powered automobiles, with experts saying that hydrogen fuel cell vehicles are safer than those with internal combustion engines. Are hydrogen trains dangerous? Hydrogen is highly combustible when mixed with air, causing some concerns over the safety of the fuel. However, since hydrogen is lighter than air, the fuel would vent quickly up into the atmosphere rather than igniting should a storage tank be punctured. This has led experts to believe that hydrogen fuel is less dangerous than combustion engines. Are hydrogen trains the future of UK travel? There are still questions over whether hydrogen trains are the future of UK rail travel, although there is every indication that Hydrail will have its place. Cutting emissions is important, especially in ground transport, which is the largest source of greenhouse gases in the UK. As such, part of the solution for UK travel as a whole must be to move more people and goods by train and less by road, which makes up around 95% of these emissions as opposed to just 2% for rail. But, will hydrogen power our railways in the future? Hydrogen could certainly replace the use of diesel trains on non-electrified tracks as hydrogen storage solutions and fuel cell capabilities improve. However, the loss of energy that comes from turning electricity into green hydrogen and then back into electricity seems to be a waste compared to simply electrifying more tracks, particularly for busier routes. The use of electric traction removes the need to store or transport fuel and is currently more energy efficient on routes with more than 4 trains per hour than either batteries or hydrogen. However, the installation of electrified tracks is expensive, which means that hydrogen could be the answer for quieter lines that are either difficult or simply not cost-effective to electrify. In short, hydrogen trains may not be the complete solution, but should certainly be part of the future of UK travel. Who makes hydrogen trains? A number of different train companies are investigating hydrogen trains, including Alstom in Germany, who launched the first hydrogen-powered commercial passenger train. These companies are also working with research bodies, such as Porterbrook in the UK, who developed Hydrophilix alongside the University of Birmingham's Centre for Railway Research and Education. Conclusion. Hydrogen trains have already been put into operation, using hydrogen fuel cells as ongoing research investigates the use of converted hydrogen internal combustion engines. Improvements in infrastructure could assist with the use of hydrogen for railway rolling stock as storage and production solutions transfer from markets such as automotive and aerospace. When produced as green hydrogen, using electricity from renewable resources to create electrolysis to separate it from seawater, hydrogen fuel is a zero-emission solution. This environmentally friendly factor makes hydrogen trains perfect for replacing the use of diesel engines on non-electrified lines. As technology continues to improve, hydrogen trains, often hybrids with battery assistance, look set to be part of a wider rail network that will still use electrified lines on busier routes, at least in the short term. Regardless, hydrogen train technology could prove to be an important part of a wider transportation network, including trams and other local travel, passenger trains, goods transporting, and industrial railways.